It's a large plastic toadstool, but not any old toadstool. This one uses ultraviolet type light to lure insects in before decapitating them and tossing their lifeless corpses into this collection area. Let me just pop this off. It's got a fan. It's got LEDs. It's not very sophisticated. And then it's got this collection grate at the bottom. Now let me just pop this back on and show you the power rating. Excuse the grubby pink power bank. I've been logging with a Sharpie the capacity each time I charge this, and it's interesting that over the time that I've been testing it, roughly every full charge and discharge cycle, it drops 15 milliamps capacity. This is normal for lithium cells. They normally lose capacity. So this thing starts off round about 300 milliamps before dropping down to about 275 milliamps, which means at 5 volts, the power consumption is approximately 1.4 watts. Right, I shall unplug it now. There we go. So the principle is simple. It's this 5-volt fan. It's these LEDs are, I think they could be ultraviolet-ish, but they look very blue. And the idea is that the insects are attracted in, then they get pulled down by the fan. And then there's this multiple mesh thing with this first layer, and then this other layer. I'm not sure why they've got this particular bit. Is it? Oh, I know what it is. It's so they can't, if you turn it off, the flies can't theoretically get out again, because they'll fly up towards light, but they'll actually fall down there. Okay, right, I've worked it out. Right, let's take the cover off this. It's worth mentioning that they claim it attracts mosquitoes. In reality, it's only going to attract things that are attracted to light, and only in a very dark room. The problematic mosquitoes, the ones that bite you, are generally looking for heat and carbon dioxide, I think, so they're not really going to be so affected by this. But this will remove things like fruit flies, I guess. So we have a little circuit board here. Let's do some tests. Let me just screw it back on here. Oh, I should mention, this was supposed to be pink. I'm slightly disappointed. The listing, which I was lured in by the big pink toadstool, the listing is just £5.99, shipped in the UK by Royal Mail. That seems really low, because I would have thought Royal Mail would be charging around about £3 or more just to ship something like this. But it came from a supplier called Little Dash Master, and I was expecting the pink one. It came through blue. It doesn't really matter. It is what it is. They make lots of strange claims, like the LEDs are supposed to last 300,000 hours. That's not going to happen. Oh, let's test that. Let's check how much current it's drawing across the LEDs. So I can see that the LEDs are wired as 6 in parallel, which is 1 resistor, which looks like a, is that a 22 ohm resistor? I think it is 22 ohm. It's a very orangey red if it is. It might be 33 ohm. Done, let's test this. Resistor. It's 22 ohm. Right, tell you what, let's measure the voltage across it. Nope. Leave that turned on, that would be helpful. The voltage being dropped across the resistor is 1.5 volts. That's lower than I was expecting. I was expecting close to 2 volts. What's it across the LEDs? Okay, 3.2 volts. Okay, so we can work out from that. We've got the 22 ohms and we've got the 1.5 volts. We can work out the current through the LEDs. So I equals the voltage, 1.5 volts being dropped, divided by the value of the resistor, which is 22 ohms, equals 68 milliamps, divided by the 6 LEDs, because they're all in parallel, roughly 11 milliamps each. That's not bad. It's not really grilling them, which is quite good. So it means it's not going to be super bright. I shall put my meter out the way. Let's pop the circuit board off. There are 8 holes, but the circuit board only has a position for 6 LEDs. ANJ6 LED. Okay. Oh, let's work out the dissipation of that resistor as well, see if it's going to get hot. To work that out, it was about, 1.5 volts divided by the 22 ohm resistors gave the current, which is 0.068 amps, 68 milliamps, times the 1.5 volts being dropped. It's only 100 milliwatts. That's half the rating of that resistor. It's less than half the rating. That's very good. Okay. Oh, I know why they've got those holes there. So it can actually go round any way round. Because there's only one screw hole. That's quite neat. Maybe there's a version that does have 8 LEDs. Anything else worth looking at? So the supply cable comes in here. It ducks up inside this pillar, comes up here. It's this brown and blue wire. The blue goes to the switch and gets switched. Then you've got it powers the LEDs, and then the red and black for the fan go down there again and to the fan. That's just the ones that are attached to this. DC brushless model DC802505SL, 5 volts, 250 milliamps, made in China, as most stuff is. Really, the cost is such that of the whole thing that it's almost like that's worth it, just the fan itself, although it might not be good quality. It might just be a cheap generic thing. But that is it, the large plastic illuminated fly attracting toadstool thing. Very strange. It's stylish, if you like that sort of thing. I suppose it would make an interesting ornament. It has hackability. I do find it quite odd that the LEDs just face down the way there and shine onto the surface. They also seem to have a slight diffusion in them. And they have that ultraviolet look, which does tie up with the fact they've got a fairly high forward voltage, that they sort of near ultraviolet. But it seems to be stimulating a bit of light output from the resin itself, giving it that washed out bluey look. But I don't think they're actually pure blue LEDs. They've got that. I think they'd be brighter. They do have that ultraviolet look to them. Interesting. It's quite well made for what it is. Don't know if it works because I don't really have many flies here to try that on. But it was certainly worth getting and taking to bits just to see what was inside it.